Histograms may come in many different shapes. A very important shape in statistics is the normal distribution. The shape looks like a bell. So we say it's bell-shaped. And it's symmetrical about the center. If a set of data is normally distributed, the mean, median, and mode are all equal and located in that center. Well, for a normal distribution, we're mostly interested in the mean. So I'll put that right in the center. And I can represent it with X with a bar over it. And one thing that we know about data that's normally distributed, since it's symmetrical about the mean, is that 50% of our data are going to be above the mean, and 50% of the data will be below the mean. Now, there's a special rule that applies to any data that's normally distributed. So I'll draw my curve again. This rule is called the empirical rule. And what that rule says is that approximately 68% of the data is going to be within one standard deviation of the mean. That's the mean minus one standard deviation to the mean plus one standard deviation. And if the data is normally distributed, we know that 95% of the data will be within two standard deviations of the mean. That is the mean minus two standard deviations to the mean plus two standard deviations. Let me extend my curve a little bit. So that's the curve almost just touching the scale. And almost all of the data, 99.7% of the data, will be within three standard deviations of the mean. So, for example, if we look at a test, let's assume our test is normally distributed. And has a mean of 78. And on the average, the other scores differ from that mean, differ from 78 by 7. Since it's normally distributed, I'll start with that bell-shaped curve. And I'll put our mean right in the middle. Now, one standard deviation above the mean, that is the mean plus one group of whatever our standard deviation is. So 78 plus 7, that's 85. Two standard deviations above the mean. That's the mean plus two groups of our standard deviation. So 85 plus 78, our mean of 78 plus two groups of 7. This is 80. This is 92. And three standard deviations above the mean. The mean plus three standard deviations. 78 plus three groups of 7. This is 99. All right, one standard deviation below the mean. So that's 78 minus one group of our standard deviation. So 78 minus 7, that gives us 71. Two standard deviations below the mean. That's the mean minus two groups of 7. 78 minus two groups of 7, 64. And the mean minus three standard deviations, which would be very close to the end. That's 78 minus three groups of 7. So 78 minus 21, that gives us 57. Okay, so what we know, because our data is normally distributed according to the empirical rule, that 68% of the the test scores will be between 71 and 85. And we know that 95% of those test scores will be between 64 and 92, within two standard deviations of the mean. And finally, 99.7% of the scores will be between 57 and 99. So suppose 100 students took the test. How many of those students scored between, let's say, 71 and 85? Well, 71 and 85, that's within one standard deviation of the mean, so 68%. So 68% of the 100 students, okay, make a decimal out of it, multiply it by 100, so approximately 68 students out of the 100 students will have scored between 71 and 85.